Hello there. We're going to try this problem involving a heptagram and finding the sum of the angles at the corners. That's going to be these guys, not the ones inside here. A similar... Oh, well, hello, Aslan. Okay, so, well, let's label the points. For the video, I made a regular heptagram because it looks really pretty, but this proof is going to work for any heptagram, regular or irregular. And one thing that I can do is I can actually construct a line parallel to another one through a particular point. So I'm going to do that over here. And we'll call this line L. This is some new transversal. Maybe we should call it T for transversal. Okay, we've already drawn L. So I'm going to mention something about L. So I'm constructing this line such that it's parallel to this one, AE, and hits this point, which is the intersection of GD and FB. And we got all that down there. And this does a couple useful things for me. So one of the useful things it does is it lets me talk about this angle here and this angle here. Those angles are, there's the transversal, there's the parallel line, so they're going to be congruent. And this angle here, we're going to label them. We'll call this one 1, that's where we'll start, and we'll call this one 2. Angle 1 is actually exterior to this triangle over here. So we get this big kind of red triangle. We'll put in some cross hatches there. So it's this big red triangle. Up here we got A, down here we got D, and right out here we got the exterior angle. So angle 1 is equal in measurement to the measure of angle A plus the measure of angle D by the exterior angle theorem. And then that's going to give us that angle 1 is congruent to angle 2 by the parallel line postulate. So up above here we actually had, and how it was given, we had that L was parallel to AE. That was one of our givens. Okay, so that's one part of it. Now, there's several more of these triangles. This overlaps quite a bit. I'll try to use different colors. So the next triangle that we're going to look at is this one. And so that's got F and C, and I'm going to be interested in this little angle up here. We'll call this angle, we can call that angle 3. And angle 3 is exterior on this green triangle. So it's going to equal the C plus F by the exterior angle theorem. And then, how do we use that next one? Oh yeah, this one does get pretty crazy. So we're just going to hold tight on that one for a little bit. Notice I can't talk about it with some of the other ones out there. So I'm actually going to bounce from that corner down to this corner. We're going to call this angle over here angle 4, and it's also part of a triangle. So sometimes you do this over multiple diagrams, but for this video I'm just going to use one. Here we have this purple triangle now, and this angle up here, little angle 4, that is exterior to that purple triangle. And this one is also true by the exterior angle theorem, so 4 is B plus E. Okay, this gets even better. There is a little tiny triangle in here. And we know 2 of the angles so far. We got 3 there and 4 there. So there's an angle out here. We'll call that angle 5. And angle 5 is exterior to that tiny little blue one right there. So we're doing all kinds of exterior angle theorems. And we got the transversal, remember, heading this way. So we can talk about angle 6 over there, and the measure of angle 5 is equal to the measure of angle 6 by the, what are those? Those are corresponding angles, so this is by the parallel line postulate. Okay, so now we have this triangle over in this corner. And that little triangle, all of those angles, so the measure of angle G plus the measure of angle 2 plus the measure of angle 6, that all has to equal 180 degrees by the triangle sum theorem. And we know that that one's true. And now it's going to be a matter of substitution. We got G there, so here we got 2. And we know that 2 was congruent to 1, which was congruent to a plus d. So that was 2, and now we have 6, and 6 was congruent to 5, and 5 was congruent to 3 plus 4, and 3 was C and F, and 4 was B and E. So there's a whole lot of substitution here. And we're really running out of space on this one. So okay, here we got all of these different letters, and we got A, B, where is it? C, D, E, F, and G. We can just put those in order. And that's always going to be 180 degrees for any heptagram you could start with. This one happened to be regular, but you'll notice that that was nowhere used in the proof. You could sketch any heptagram and you'd be able to construct these lines and all of these gorgeous triangles and using that exterior angle theorem. Whew, okay, got there. Character and Scholarship for Life.